All right, my friends, just to make sure, depending on your experience with factorial, off to the side, let's just make sure you're okay with the definition of factorial. Definition of a number with the exclamation point after it, or n factorial is how you should read that. So a number, if they say factorial, it basically means that you multiply starting with that number, and then the next factor of your answer would be that number take away 1, and then the next factor would be the original number take away 2, and you just keep subtracting one more and multiplying the results until you get down to 1, and then you stop. I hope it makes sense. You don't want to keep going past 1 because then your answer would always be 0. Yeah, exactly. Anyway, so that's the definition of n factorial, okay? So some notes, there are some fun little tricks that you can use. So there are different ways to split a factorial up. You could always, expand it all the way, but I hope it makes sense for part A. You wouldn't want to expand 73 or 74 factorial. So n factorial could be thought of as n, and then I hope it makes sense like the rest of n factorial could be thought of as n minus 1 factorial. Or you could have, taken n factorial and thought of it as n times n minus 1. And then what would the rest be? All that. That would be n minus 2 factorial. And so there are lots of different ways that you could choose to express a factorial, and you can kind of pick whatever suits your situation or your current condition. I don't know why I said it that way. Anyway, whatever. All right. So for example, with 73 factorial over 74 factorial, I personally would recommend you always start with the factorial with the larger base. And so in this case, it would be 74. And think about, okay, well, what would this equal? Well, it would equal 74. And then what would the rest be of 74 factorial? That would be 73 factorial. And then if you do sound effects when you cancel, like if you cancel one number over another one and you go choo-choo, then if you cancel 73 factorial, then you're canceling 73 different numbers. So it should kind of go like, what would that be? Like, can I do a machine gun sound? Like, I don't know. That's my best machine gun sound. Anyway, if you got 1 over 74, then you probably know what you're doing on that one. Okay, that was a warm-up, though, for you to be able to do this in terms of n. So let's look at part B here. Really, this, my friends, parts B and C, that's our bread and butter. Part A was just a little warm-up, just so you know, okay? So for part B, I'm going to do the same thing I did with part A. So which one should I expand? I should expand the one with the higher base. And so I'm going to start thinking about, okay, well, what would n plus 2 factorial be? It would be n plus 2 times n plus 1. And then what would the rest be? The rest could be thought of as n factorial. And then the reason I split it up that way is because I really want to simplify this. The best thing to do with factorial is to get rid of it, in my opinion. And now I can cancel. There we go. Anyway, so your final answer could be written as n plus 2 times n plus 1, or you could be extra fancy and multiply it all out. Either way, we'll just box up both of those expressions. There we go. Hopefully this is making sense, my friends. Okay, so now let's look at part C. You've got 2n minus 2 factorial and 2n factorial, and which one would be greater? I hope it makes sense. 2n factorial would be greater. And so when I start trying to cancel this down, I would actually just leave 2n minus 2 factorial alone. And then on the bottom, I would multiply 2n by, then what would the next number be? Well, it would just be 2n minus 1. And what would the rest be of this expression? The rest could be thought of as 2n minus 2 factorial. And so your final answer could be 1 over 2n times 2n minus 1, or you could be fancy and distribute the 2n in. So 4n squared minus 2n. There we go. Either of the last two would be considered correct. Oh man, I hope this is making sense, my friends. If not, ask me for help with factorial. It's going to be an important part in bigger problems later. All right. Example 4 is our last example, and then I'll just kind of like make sure you're good with the vocabulary of monotonic and bounded and stuff like that. But Anyway, so for example 4, write the first 5 terms of each recursively defined sequence. These can be a little tricky at first, but once you get used to them, it's no big deal. So for part A sub 1 is 4, and your rule is that A sub k plus 1 is equal to A sub k plus 3. And for part B, it's a little more complex. A sub 1 is 0, A sub 2 is 1, and A sub k plus 2 is equal to 5 times A sub k plus 1 minus A sub k. All right, give it a shot, poke it with a stick. I'll go through it with you in the next video.